Welcome everyone to ChessWhiz Arcade episode 9. Today is July 9th, 2015, and if you're looking for chess, look somewhere else. This is not ChessWhiz TV chess, although the last episode 151 was anti-chess. So if you're looking for non-chess, I guess you could go watch the anti-chess episode. But this is programming. So here we're making a web game called Uprising, which is played on a chessboard, so it's like chess, but it's not like chess because it's not a chess game. It's a real-time, it's not really a real-time strategy game. It's not an RTS, but it's a real-time game, and I'm trying to make a multiplayer here. That's what we're working on, where you move a knight around the board and capture pieces before they become king. So let's see what we've got so far. Let's go to my desktop view here and see what we've got. I've got to fire up my Visual Studio, chesswiz.sln. I named the solution after myself because that's the kind of person I am. Egotistical, or maybe just statistical. I'm one of those. So here we are in Visual Studio. Let's start up the game and just see what we've got. What I want to do today is allow the server to time travel, which is why the episode is called Time Traveling Server. The challenge we're having is the server gets a move at a specific time, and if the person sending in the moves is cheating, that is to say they're announcing moves out of order or moves ahead of time, then the server says you can't make that move. That's what we got last episode. We said you can't make that move now. Let's put it aside in the moves to go and then execute it later. The problem is later doesn't really have a trigger to it. It still gets executed now. So if you send moves 5, 6, and 7 in, the server says hold on, you haven't sent move 4, then you send in move 4. It'll fire 4, 5, 6, and 7 immediately. Now in the database it actually stores that they happen the proper spacing apart, which is the speed limit of the piece. But it executes them immediately, so logistically speaking, it's not actually spreading them out in time, which allows for cheating. It allows you to execute a lot of moves all at once by sending them in with the first move last and the last move first. So we need to change the code so that the server does not care what time it is. It executes a move, and you can just say, well, execute this at millisecond 25,000, and it will happen at that time, even though you're running the code now. So the server is not moving through the game the way the browsers are, the way the players, clients, software are moving through the game. You see the chess piece moving, but the server is everywhere always. It's kind of like omniscient, although that means knowing everything. It is, in that sense, omniscient, or perhaps it's everywhere at once. Omnipresent. That's what this server is. So here we are at ChessWhiz TV, chesswiz.tv/arcade. That's not where I want to go. I want to go to localhost, my favorite website. Localhost port. See if this works. It's loading right now. Localhost port 49675 is the ChessWhiz TV website. You go to the arcade tab, and now we go play now. We're playing Uprising. Let's bring up the Chrome developer tools. So this is the game we have so far. You move the knight around, and when you capture something, the server sends the next piece. So when you make a capture, it sends a message to the server and says, hey, I captured something. And then the server replies, hey, here's where the next piece is. It goes right here on A3. So this is the game right now. You capture these pawny things, and new ones appear. It's pretty fun. You can control it with the mouse. You can control it with the keyboard also, but it's super hard because knights are really confusing, so most people don't do that. Nobody does that. So that's the game so far. The problem is if you actually hack your client to say, I'm moving here first, and also here, and also here, the server will say, okay, those can't happen, but I will remember that for later. And then you move here. At that time, it executes all of these immediately. Now, we did space them out last episode so that they don't happen immediately according to the database. It says this millisecond, this millisecond, this millisecond. They're spread out properly, but it's executing them right away. So we need to change the code completely around so that the server is time agnostic, which means it doesn't know what time it is. Time agnostic. It's a new term. It's a ChessWhiz TV term. Okay, so let's go to the code. See what we got. What do we got? Let's go specifically to the database, okay? So we're storing in a game. We're storing the list of players and the list of enemies. That makes sense. The enemies are the things you capture. And each player has a current location. That's not going to work anymore. I've done some thinking between episodes, and I realized the current location depends on what time it is, but the server needs to be time agnostic. In other words, I got no idea where you is. So I'm actually going to delete the location of the player. In order to tell where you are, you're going to have to... Whoa. 1 sec. Okay, I'm back. That was amazing. If you watched it on YouTube, you probably tried to find the spot in the video where ChessWhiz came back, but I'm back now. What I saw there was outside of my window was, well, this should look like this. Outside of my window, something flew past the window, and I'm on the second story, so you don't want to see things flying through the air on the second story. It was very discombobulating. So you can imagine I had to go do something about that, which is namely tie down those objects a little bit better to the ground so they won't fly around. Let's get back to what we're doing here. So I just removed the positions. The player does not know where he is. Depends on what time it is. So now let's go to a move object. This is a move. It says which player moved. It says when he moved. It says what move number it is, 1, 2, 3, 4, etc., and which direction you are moving, and whether or not the move has yet been executed. The next thing we need to store here is where the player ended up. And I actually think I want to make a separate object for pending moves and executed moves. Instead of just having an is pending flag. So I'm going to do that right now. I'm going to add, what you can't see right now is the menu. Add a new class. I just added a new class, and it's going to be called Uprising Player Move. Uprising Player Move Pending, or Pending Player Move. Pending Player Move makes more sense, but a pending player move does not have a lot of the stuff that a player move has. For example, it doesn't have the destination. Was it pause X? Pause or position? Just call it pause. And position Y. This is a real move. It knows where you moved and it knows where you ended up. But don't really need to know where you moved anymore. Only need to know where you ended up. So a pending move has the direction in it. And a pending move does not need a millisecond number. It simply needs a move number. It's going to say, okay, move 7, you're moving in this direction. Move 8, you're moving in this direction. That's all you need to know. You don't need to know where you ended up because you don't know yet, because it's in the future. And you don't need to know when it occurred because it occurs in the future, so you don't know that yet. You need to know the move number, and you need to know the direction. Now, after it's been executed, then you need to know when it was executed. You need to know, still need to know what number it was, and you need to know the destination. So this is completely changed around. Now, a player, instead of just having a list of moves, also has a list of pending moves. So this is Uprising Pending Player Move. Now, I'm actually going to rename that to Pending Player Move from Player Move Pending because I just blew my mind with those words being backwards. Okay, there's the pending player move. And of course, the context itself, which has a list of everything that exists anywhere, needs a list of this. Okay, so context has it. It exists. It exists on every player. And we're good. I think we're good. And a game has a list of players, but the player has the moves. The game doesn't need the moves. Okay, so now we broke the compilation of the program. I assume when we build this, we're going to have a lot of build errors because I just took out the position of the player from the player itself. Is move off board fails, for example. So we have to do some refactoring here so that this builds. For example, this is something I hadn't considered. When you create a new game, the player needs to have a location. I'm not going to make a two-player game yet. So position, so this is a new player. Instead of giving a position, because he doesn't have that, he's going to have a list of moves. Uprising player moves. And there's going to be a move in there. And new uprising player move. So this is initializing a new player. The first thing it's going to do is give it a list of moves. And move 0. I think that war is breaking out, actually. I think I need to be right back, actually. So unfortunately, this is reality. I'm going to be back as soon as I can. It's probably going to be about 45 seconds. Be right back. Okay, great news, guys. Great news. The Germans won. The war is over. And we're back. Okay, where were we? Ah, yes, new Uprising player move. So we need to have a move. Now these have an ID, which I don't have to set. Move number -1 is going to be the first move, because it's like where you are. Milliseconds is 0. Is this going to work? Position X. That's how many in, so 0. Position Y, 7. Uprising player. Don't have to set that because it's already a reference. The player is adding it to the list. So the 0th move is interesting logic. When you create a player, he always has the 0th move that exists. And that is just the way that we make it time traveling. The server is time agnostic. Does that make sense to you? Let me say that again. When you make a new player at the start of the game, he comes with a move. It's move 0, and it's his starting location. And the moves then have the following locations at the following milliseconds and their move numbers. Now we may not need milliseconds. We do. We may not need move numbers. We may not need move numbers. We do. I think we need both. It's interesting because if you know the milliseconds, you should know the number because they're always incrementing. But you certainly can't tell the millisecond from the move number. So maybe we can get rid of the move number, but I think we can't because this client says, okay, move number 8's coming in, and we're like, right? We have to say, okay, we just finished 7. Great, I'll execute that immediately. So now let's see what else is broken. So that's going to work for now. Can't spawn where the player is. I think I'm going to do something cheating. I think I'm going to add. So this is the player. I think I'm going to make a read-only property, a getter that gets the player's position. There's something wrong with my IntelliSense here, though. I'm missing the word get. There we go. So I'm actually going to make this thing know where it is here in the logic. Now this is kind of bad to put logic in the data layer like this, but I'm building this project so I can do it however I want. First, x such that x dot ms How do you find the max? See, max is going to return the actual millisecond. Sort by the milliseconds. Dot first. It's order by. How did I get that wrong? So that actually, all the red squigglies are gone, guys. I just programmed. You just keep typing things until the red squigglies are gone. That means the code will work perfectly if you ever run it. But I don't recommend running it. I recommend just pushing it out there and let the customer run it. If there's any problems, he'll let you know. That's my version of testing. Just let the customer see if it works. So this code says, okay, a player does have a position X. You simply, to get it, you take the player's moves and you order them by milliseconds, and you order them by milliseconds descending, actually. Is that a word? Yeah, nope. Order by descending, which finds the move. Wow, that's interesting. It sorts them. Whoever's finished the highest millisecond is now first in the list. Then you take the first, and then you return its position X, and then you get a red squiggly right here because it needs a semicolon. Dot position Y. So it's like, what was your last successful move, and where did you end up after that? Oh, you ended up right there, then that's where you are right now. So that could work for X and Y. don't like how it's one thing I don't like is how it runs this query. It's not really going to matter, but it's kind of slow because whenever you read pause x, you also read pause y. It's not like you only want to know where it is in the x. Obviously, the next thing you're going to ask is, and where is it in the y direction or dimension? So you're always going to run both of these, and of course, they're going to go sort these things twice, which is kind of stupid. You really only need to sort them once. So I'm tempted to make a thing called a position, which I'm actually going to do to add this to my data layer. I'm making a class called position. Now this is kind of revolutionary. I'm doing this on the fly. I don't even know if it's a good idea. But this thing can now return a position and returns a, this is going to work. I've got so this is reducing it down to one line. The player now has a position thing, and to get it, you return the last move by milliseconds, and you get a new position where the x is the x of where it moved, and y is where the y where it moved, and then you just take the first one, which is the top. Now this should execute really quickly because all of this is already in memory. It was pulled when you pulled the game, so it's not like it has to go out to the database and get all this stuff again. It's already ready to go, so it's just got to sort it all and return a position, a new position object which has those positions. So now, thanks to the fact that I named it position, nothing's going to build. So we can at least go make sure this makes sense everywhere. Now it's kind of silly that I don't cache it at all, but I'm not going to optimize that just yet. So now there's another thing called position, and it's now ambiguous, but it's identical because I already had something called position. ChessWhiz.web.areas.uprising.models.position. That is actually the identical class, so I'm going to delete this one and just use the data layer one. I think that's going to be not a problem. We'll find out. Okay. Can't spawn where the player is. Player.position.x and player.position.y. Now it pulls the position out. It's still running the query twice. Oh, I'm a doofus. Because it still says, well, what's your x position? And of course, I could say the position equals player.position. And then, access the thing twice. But this is stupid. I'll optimize it later if I want to. Running it twice instead of once is not that slow. Not when it's already in memory. What would be slow would be if you queried the database twice to see, oh, that move was last. Let me check the moves again, right? But that's not going to happen every time. So that's a different kind of problem. Here we're saying, is the move off the board? Fine, I'll do it. Watch this though. Ah, almost. Alt and then mouse drag, and you can draw boxes of text. So I fixed that code pretty fast. So apply move, that's going to be changed around, of course. See what else is broken. Missed an angle bracket there. Okay, apply move. What else? What's broken that's not an apply move? Is only apply move broken? No, this thing, which is move player. So this is Uprising ending player move. Execution time equals this. I'm going to abstract a little bit of complexity away from that. Penting player. I'm missing a reference from the move back to the player, the pending move, so let's put that there. Oh, and I definitely need an ID, so let's also put an ID there. It's a database ID, because this is in the database, so it ought to have an ID, don't you know? Let's see what else we've got. Read only is not valid for this item. Well, I think I've got the word position here. Why is that not valid? Fine, I won't use it. Is that better? It's still kind of wiggly. Yeah. There's no such thing as pending. So if the player's .move number is equal to the move number, then apply the move. Okay, so this is all very simple, and I don't need to do much here. So I'm creating the pending move and then applying it right away. Great. I think that's going to work. Let's see what else is broken. Apply move is broken, and apply move is broken, and is pending. Okay, I need to build so I can see better errors. So what's wrong with apply move? It has some invalid arguments. I don't think I changed the arguments to this thing. The clients, the game, the player, and the move. Oh, well, now it's a pending move. Well, let's change it so it takes in a pending move. Here I am in this call. Uprising pending player move. And then let's also go milliseconds. The execution timestamp. We're just going to call it MS for milliseconds instead. Super much shorter name. Okay. Okay, so now I need to pass in the execution time as well. Store the pending move goes here. Let's clean up the comments a little bit. Calculate the millisecond on which to execute the move. For which, sure, let's improve the grammar of our comments. It's a very good idea when you're a programmer. So now we get into the nitty-gritty, which is the move function, the apply move right here. Here we go. We're going to apply the move. And the difference now is that we're going to apply it at a specific time instead of applying it right now. So first, apparently, we want to make sure we're not moving off the board. How many different calls are there to this? This is the only place this is used. It's a little weird. It's called the pending move. Let's remove the pending move at the end. And let's add the move, which doesn't exist. So let's create that. Rising player move. So here's where we get rid of the pending object and we build the real object. And its position x and y are equal to the pending moves x and y. We don't need the player here, we just need the position. There we go. Looking good. Is this getting less squiggly over time? Could be. What size was that squiggly? Should be commas here. Getting cleaner, kind of deleting some code, moving some code around. Great, we've finished that section. So we pass in a pending move, and it's going to remove that from the list and then add a move to the list. So ms is equal to the ms that was passed in. And what else can we set here? The move number. Where are we going to get the move number? Is a little bit convoluted. What else do we have? The player. Don't need that. The ID, we don't need that. And the move number. Okay. I guess I should pass in the move number. Or maybe the pending move has the move number. It does. Great. Good. That makes me feel a lot better because I didn't want to pass it in. So this thing is going to make a new real move. It's going to say you're moving here. And look at that. I can have a trailing comma and it doesn't complain. Increasing the next move number. Captured enemy equals. And then it's finding if there's any enemies that are in position.x. Oh, this isn't right. You have to add your old position to your direction. And if there are any enemies in your destination location, then you captured something. Then remove the pending move and add the real move. I think the whole thing might build right now. That'd be pretty cool. Build! The thing builds. So we changed the database, which broke everything, and now it builds. So that means obviously that it's going to work, guys. Is this going to work? I'm interested to start up LinkPad so I can see the database while I run. Let's try it. So as soon as it starts, it's going to do something it's never done before, which is create a player with a move. Could I please run a SQL query and delete from Uprising player moves, because that table is big. There we go. Now there's no moves. Okay, refresh. So it should create a player and add a move to it. So let's see if it's crashing. It's probably crashing. Let's find out what's happening in debug mode. Now is the fun part. Debugging the code that you think is should be working but isn't. Refresh. Loading good, and bam! Error occurred. The context has changed since the database was created. Duh! Okay, so when you change the code for your database, that doesn't mean it actually changes the database schema, which is why there's no Uprising pending player moves over here. The database doesn't have that table, so I need to do some things to do that. And over here, I do exactly this. Go to the data project, and I say add migration, add moves. And bam, it's going to produce the SQL that is necessary to add the table to the database and all those other changes. Here it is in code. This is in C#. We've got, it's creating the table with all these properties. It's giving it a foreign key, primary key, foreign key into players, index. It's adding some columns, X and Y. It's dropping some columns from the player moves table, like direction, because that's now stored in the pending section. So now we apply that with the command update database. Now chances are something broke, but let's just take a look at what happened here. So there is now a table called Uprising pending player moves, and if we look in it, .table 100. There's nothing in it either, of course. I knew that, but now let's see what happens when we run the game. Ready? Go. So now it should add a move as soon as this loads up. Any moves in here? Any moves? Any moves? Yes! There's move 0 and millisecond 0. Go! Is there another move? No, it crashed. illegal move. X is 2 and Y is 1. I'm looking here, and that doesn't look illegal to me. Why does it say illegal move? And why does it say it on this line? Shouldn't it say it up here? That's what it means. Ha! X is 0 and Y is 7, right? So why did the knight appear up in that corner, which is 0, 0? There's something, teleporting knights are blowing my mind. Let's go back to the hub that creates the game. So I'm going down to the browser to see when you call start game what really happens. Scripts, hub manager, start game. So it gets this model, and I'm not sure what's in it, so let's take a peek. It's this. It has a list of players. So pause Y should be 0, and pause X should be 0, and pause Y should be 7. Oh, I changed the model. Now pause X and Y are 0. See what I did there? The server moved the X and Y into a new object, the move list, right? But when I send that down, the client is looking in here, and it doesn't exist in here. So let's take it out. Actually, let's leave it there. Let's add it to the model. Here's what I'm doing. Player model. This is the model of what's coming from the server to the client. Currently doesn't have an inherits from piece, which has the position. It's an auto mapper thing. It's a mapping. Right here. I'm mapping from Uprising game to game model. For the member, oh, it's really a mapping from player to player model, isn't it? When I map from the server's player to the client's player model, I need to say that for the member pause X, I forget how to do this. Fortunately, I have the internet to help me. Auto mapper for member. That should do it. Oh, look, I've already been here. And you say, you do it like this. Copy and paste magic. Des.this property. Opt.map from source. Here we go. So this says for every, if you're mapping position X, get it from the sources moves dot order by descending milliseconds dot first dot pause X. Did that make sense? I don't know. So this code says whenever you're going from an Uprising database player to a model that's going down to the browser, whenever you need to map the position X, map it from the top move, the most recent move, the first one, the most recent, and use the position X. And then do the same thing whenever you're mapping position Y, get it from this position Y. That'll happen whenever we map. So that'll help the client to know what's going on. And something's up with my parentheses. Yeah, it's okay. It's built. It's okay. Let's try it now. I'm just going to run it. See how it works. So the issue was that the knight needed to appear down. Whoa. 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 the knight needs to appear here. And it appeared up here because it was 0, 0, because it couldn't find that property, so it defaulted to 0. But when I refresh now, the knight should appear at this corner, which is 0, 7. And then my first move, of course, was moving down and to the right, which failed because down and to the right is illegal from this position. So now it's in the right spot. We fixed it by changing AutoMapper. Guys, that was pretty cool. It's pretty cool how we found that bug and we fixed it. I thought it was cool. So now let's see what moves are in the database. There's no need to order this. It's already ordered by ID. I just lost. There's move 0. So there's 2 move 0s. That's one thing we see because it automatically inserts number 0, and then it of course counts starting at 0. So there's 2 zeros. So I'm actually going to do the world's hackiest hack and say that the first move is move -1 because it's not a move. It's where you start. And the milliseconds for that is actually -1 times globals dot speed limit. ms per move, which is how many milliseconds you can have between moves, or 150. So it's going to say your -1th move before the game occurred 1 speed limit ago before the start of the game. So now it can never get in the way because even if you make a move right at the 0th millisecond, you're obeying the speed limit. You're not moving any quicker than that. So let's see if this works again. This time it's going to add the -1, which is going to be so convenient. There it is. Player 78 on his -1th move appeared right here. Then on his 0th move, he appeared at 2-6, and then he appeared at 0-5, and then he made a whole slew of moves moving like this. Now he's at 6-6. Let's go capture that queen. I lose anyway. Okay, so that works, and these are the milliseconds at which they occur. The first one occurred in negative time. So now I'm going to try moving right away. And that makes it crash, I think. Okay, so -50, and then wow, 3 seconds already passed. I think that's because of the get ready thing. I haven't synchronized that. I should do that. The 3 seconds, that's 3,000 milliseconds. Did we get a crash? Why can't we move anymore? Oh, we can. That was dubious. Is that going to turn into a bishop? It does. Well, this is interesting. It's time. Now is it time agnostic? That's what we wonder. So now let's add the cheating mode. Where is the cheating mode? Let's pretend I'm a cheater. Let's go on my client software. Save, no, not there. Let's close that. Whoops. Close that. And undo those changes. Source control, undo, because I don't want that to be marked as a file that was changed. Is it a piece that moves? Yeah. Simulate client lag by uncommenting the set timeout. Okay. We have now added some code that says each move actually occurs 1 second late. So we might actually see them pending. Oh, what we'll see is them out of order. See how badly this breaks. There's some pending moves. There's the directions. And there's the moves executed later. Hey guys, it works automatically. It doesn't work. Oh, wait, I want to try that again. So you execute these moves really fast, and it puts them all in pending because it hasn't received the first one yet. And then, eventually, I just broke my query. And then you move again. And these pending moves never go away. Now they do. I just deleted them. You have to send moves in the wrong order in order for them to stay in pending. This is going to start getting hard to watch because because it's going to be so confusing. But instead of waiting 1,000 milliseconds, let's wait a random number between 0 and 1,000 milliseconds. And I'm sure this is going to be really buggy. But it's going to be like, okay, your first move, I waited half a second, and then I sent it to the server. So there's some moves, 0 through 9. They all occurred in their proper order. There's some pending moves. So there's something missing, obviously. I haven't finished my coding. That was a fun exercise. Need to think about this. Move comes in, store it as pending. Add it to pending. Then I need to execute every move. I want to execute every pending move whose move number is equal to next move number. So this could be while player.pendingmoves.any. While there are any pending moves that have this, then we should get that move. This is bad. I'm writing the query twice. And then execute it. So this code should work, but I don't like how it just keeps on running all of these mad queries. So whenever a move comes in, it adds it to the pending list, and then it just keeps on looking in that list to see if there's any moves that still need to be executed. But this is a local variable naming conflict. I think there's a better way to write this, which would be players.pendingmoves. If there are any pending moves where the next move number is equal to the move number, first or default, or reply with the first one like that, unless there aren't any, in which case it will return null. So I'll say if the next pending move is not null, then execute the next pending move. Or the execution time needs to be pulled down. This is interesting too. This is very complicated. This is like the guts of the engine here. It adds to the pending list. Then should it calculate the millisecond for which to execute the move? Yes. But it should only do that while there are any moves that should be executed. While there are any moves that should be executed. I know I just deleted this code, but now I'm adding it. Then do all of this stuff over and over. For every move, you should calculate when that move should be executed, which is either now or soon if you're disobeying the speed limit. And then it should execute it. Okay, that code is okay, except it does have the query twice. First, it sees if there are any, and then it gets the one that existed. So if C# were a little bit crazier, you could actually say something like, while pending move is equal to the first or default of that is not equal to null. This is the way you might write it in C, where first it evaluates this and assigns the query to P, and then it evaluates this section and says, is P null? Oh, it is, and then it skips it all, or oh, it's not, and then it enters here. But you can't do that in C# because it's so confusing that it's only permitted for experts, which would be C programmers. Or C++. I think you can do it in C++, which is way more reasonable. So I guess I'll just run the query twice with any in it. There might be a pretty cool... I mean, if you're watching on YouTube and you know how a better way to do this, then post it in the comments, because I'm kind of curious if you should say first or default first, but then put something in a while loop that... Maybe it's a do while. Maybe this should be a do while. There's do whiles in C#. Do... Yeah, let's try a do while. Never mind about the comments thing. I don't want to hear from you. This. This is the right way to do it. There's only one query this way. There's only one time that you look in that list and find if there is any that match. It says it gets the next pending move, and then, if the next pending move is not null, then it runs all this cool stuff. And if it is null, well, then it will exit the loop. Does that work? No. Oh. This is outside the scope of this thing. And if I put it over here, then I've got a different problem. Which is I have to run the line twice. This seems way more complicated than just writing the query twice. So this is execute all pending moves, including this one. So it gets the next pending move. If there was one, then it gets when to run it, and then it applies it. And why do you have a problem? Don't be silly. It's declared way up here. Let's just build. Oh, bar. That's the problem. And then it'll calculate the next one. As long as it doesn't exist, it'll go around, it'll apply it, it'll calculate the next one. This will run fast because it runs each line of code once, but it takes up more space on my screen because this line of code and this line of code are almost the same. So maybe you should write in the comments and tell me the correct way to do this. Anyway, it's going to work. And it's going to be awesome. I have to run it in debug mode. You guys getting tired? There's almost nobody left watching, but that's okay. I don't care. I'm just programming by myself here. It's all right. I don't mind if you don't watch. People are actually coming in like, who's that guy staring at the code? I'm going to leave now. Okay, I just deleted all the moves. So I better refresh the page. Okay, ready? Go. Move there. And it moved and it exists. Go. Oh, that's interesting. This is interesting. Let's go capture that queen really fast. I want to see what pending moves there are. Go really fast, like this, and then I broke the code. It applied a move out of order. I don't even know why. But it said I made an illegal move, so that's applying a move out of order. Oh, I think I know why. It's a problem with way the code works. I don't know. I got a headache. The server kind of works, but it's really hard to test this way. Hey, there's a bunch of pending moves. There we go. Want to see them cleared out? I will simply see moves 14, 15, 16, and 17 are existing there. And there's no moves that exist, so they're there because I broke them. Number 18 exists there now. It's never going to get there. So now it's adding them into the pending move list. But the player who's this guy, is currently on move 8, and there's no way he'll ever get off of that. Because, well, I'm thoroughly confused. So I'm actually going to call it a day because it's a lot of work to confuse yourself with this stuff. But the idea is that the moves come in, and if it's time to execute them, then you do right then. And if it's not, then you set them aside, and then when another move comes in, then you execute all the ones that are waiting. That's the idea, and it's half working and really hard to test. So it was a fun episode anyway. We're going to work on all this a little bit more next week. This has been ChessWhiz Arcade, episode 9. Thanks for watching.